In sensing, quantum sensing is basically trying to push sensor technology to the limits set by quantum mechanics, which you can't really go beyond. And quantum communication, which is the third area of development, is one that promises a kind of encryption that cannot be broken by any means. So completely secure communications. So quantum will really revolutionize those three areas. The sort of explosion in interest in quantum as a technology has led to a large number of both big and small companies investing serious resources in this area. And as a result, there's an enormous demand for a workforce of trained people that can contribute to that commercial effort. And I see one of my roles is producing those students. All of my students in the recent past have gone to places like Google, joining their quantum effort, Amazon, joining their quantum effort, and people going to various startups. So definitely that kind of workforce development is key. One aspect of that is that we have a world-class nanofabrication facility, the Pritzker nanofabrication facility. It's a clean room, primarily used by students and postdocs, both from UChicago and from neighboring institutions. And the students that go in there learn how to make quantum devices. And then they come out of that clean room into the labs and they do measurements to show that those devices work as promised. And those are skills that they take with them to the commercial sector.
The students will experience this type of collaborative culture, nature of this type of work, so that when they go to their future jobs, they can, really replicate this type of collaborative efforts. And we have also a new training program funded by the National Science Foundation for graduate students only. This is called NSF Research Traineeship Program. We're trying to train our graduate students to be equipped with not only the molecular engineering knowledge, but also artificial intelligence and social science as well. So we are hoping to really convey this holistic approach to design engineering solutions, right? When you design a technology, you look into the fundamental science to develop that technology, but you also need to be mindful of potential negative consequences of those technologies. So that's where the social science perspective can come into play. Mm-hmm. So that's a really unique experience for our graduate students that really makes them, their graduate school or undergraduate experience very enriching, I would say. I certainly, have the privilege to also play a major role as a lead water strategist, for example, overseeing all the water-related research and innovation efforts that can potentially build a stronger partnership between the PME and Argonne, right? I know Dean Tirrell and other colleagues have been, really working tirelessly to build a stronger partnership, and we are, doing very well, very well. So students are the beneficiary of this partnership eventually, right? So I'm sure, Andrew and Matt can also talk more.